At present we shall discuss about the pedal form of a polar equation. What is the pedal form of the equation? How to derive the pedal form of the equation from the polar equations in the simple form, that we shall discuss. So what do you mean by pedal? Pedal. So we write the pedal. So this length y is equal to small p. We have written small p will denote pedal. Small p will denote pedal. The big P will denote a point on the given curve. Point on the given curve. R is equal to f of theta. R is equal to f of theta is the given curve. Here R is equal to f of theta is the given curve. And Py is the tangent to the curve. This Py is a tangent to the curve at the point P. And Ox is initial line. Ox is the initial line. O is called as fixed point. And the shortest distance from this fixed point or pole to the point P, it is called as radius vector r. Radius vector r. And the angle between this radius vector and the tangent vector, we call it as theta. So the relation between r and this factorial angle theta is given equation of the curve. R is equal to f of theta. So this will represent polar equation of the given curve at the point. So at the point P r theta, let us denote Py as the tangent to the curve. Now this length Oy is called as pedal. Small p is called as pedal. And the relation between P and this r, the radial vector, that is we write it as P is equal to f of r, will represent the pedal equation of the given curve. So to find the pedal equation of the given curve, we consider this triangle OYP. We consider this right angle triangle OYP. We note that OY is nothing but perpendicular from pole to the tangent. Perpendicular to the pole to the tangent. So this length is called as pedal, and therefore this angle is 90 degree. So in the right angle triangle OYP, this angle we call it as pi. The angle between the radius vector and the tangent vector, it is this angle pi. Therefore we have sin pi is equal to opposite side by hypotenuse, that is p divided by r. Sin pi is equal to p divided by r. Therefore we write p as r sin pi. And we know how to find this expression for pi. We have tan pi is equal to r divided by r dash, or r divided by dr by d theta. From that expression tan pi, we obtain the expression for sin pi and substitute in this equation. P is equal to r sin pi, and we get a relation between p and theta. P and theta. So it may be P is equal to g of theta, say. And between these two equations, P is equal to g of theta and r is equal to f of theta, we eliminate theta, or we replace theta by r, and we get the what we call pedal equation of the curve. P is equal to f of r. So this is the method. ಏನು ಮಾಡ್ತೀವಿ ಅಂದರೆ ಫಸ್ಟ್ ಕೊಟ್ಟಿರ್ತಕ್ಕಂಥ ಗಿವನ್ ಕರ್ವ್ ಆರ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಎಫ್ ಆಫ್ ಥೀಟಾ ತೊಗೊಳ್ತೀವಿ. ಆ ನಂತರ ಡಿಫ್ರೆನ್ಸಿಯೇಟ್ ವಿತ್ ರೆಸ್ಪೆಕ್ಟ್ ಟು ಥೀಟಾ ಮಾಡ್ತೀವಿ, ದಟ್ ಈಸ್ ಡಿ ಆರ್ ಬೈ ಡಿ ಥೀಟಾ ಕಂಡುಹಿಡಿತೀವಿ. Then we write tan pi is equal to r divided by dr by d theta. From that expression tan pi is equal to r divided by dr by d theta, we obtain an expression for sin pi and then for pi, and then substitute in this equation. P is equal to r sin pi. So the resulting equation is in the form of P is equal to g of theta, a relation between P and in terms of theta. Then again from the previous equation r is equal to f of theta, and with this equation P is equal to g of theta, we eliminate theta between these two equations and we write P is equal to f of r as the pedal equation. So let us consider few examples. So to obtain the pedal equation, we eliminate theta and pi between the equation p is equal to r sin pi and tan pi is equal to r divided by d theta. So try to find out the pedal equations for these curves. Let us take r is equal to a into e power theta divided by 1 plus theta whole square. Second example, r to the power m is equal to a power m cos m theta. Third equation, r is equal to a divided by theta. 4 equation is r is equal to a into e power theta cot alpha. And fifth equation, let us write L is equal to r into 1 plus e cos theta. Sixth one is r is equal to a into theta. Seventh one is r is equal to a into 1 plus cos theta. And eighth one is r is equal to a into sin m theta, and so on. So try to obtain the pedal equations for these curves. What is required? You first differentiate. In the first step, you differentiate the equation of the given curve. Differentiate the given equation of the curve, and then find out tan pi is equal to r divided by dr by d theta. And using this expression, find the expression for pi and substitute in this relation p is equal to r sin pi, and you get p is equal to a function of theta. And then eliminate theta between using the given equation of the curve and this one.